Hello everyone and welcome to a new video. Today we are trying to collect data, so I will show you pretty quickly now. So we are on the highway right now. You can see we have the phone here running Droid Cam, and the phone is connected to my laptop down here, and here we see we are getting the live image and also we are getting the CAN data. Since here's a panda connected, a white panda. Additionally, we have running a GPS sharing app. We are sharing the GPS via Bluetooth, which reports us the accurate velocity. And so we are collecting data, and we have a 90-kilometer drive now. So we should get some good training data. So now we are driving at a residential road, and here again we see the CAN bus messages, and here we see the camera. So there's a slight lag between those two. I don't know if it's a USB interface here. It's a 3.0 interface, and also my phone should be fast enough to output this. So maybe it's a lag between OpenCV and the capturing in OpenCV. So maybe we have to write this in C++ and doing and rewriting that, and just Panda backend or the Panda client in Python, so we can merge those two. And yeah, here again the screen is dimmed because it consumes a lot of battery, because it crops the image on the phone and then it just receives it here on the laptop. So we're around 60 kilometers in, and yeah, we keep on driving. So here we are home again, and also the bug I had with the OpenCV and that there's a lag. I fixed that bug by just turning down the cv2.wait key function. So the function causes that I had it at 40 milliseconds, and 40 milliseconds is 20 FPS or 25 FPS, and looks like Droid Cam was sending too many frames. So there was kind of like a buffer overflow or buffer error, so it was always reading back the buffer, and so I fixed it by turning it up to 10, so it does 100 FPS. So I also had done a lot more images. So now in total we have around 200,000 images driving today, and also a lot of data with that. And also, by the way, if you want to use this code, you can actually. So you just need to change a few values, and if your car already has a DBC file, it's gonna be very easy, because currently it's optimized for the Mazda CX-5. And you can also just shoot me a pull request, and I will merge this in. So you have to find a few parameters in the DBC file. I'm currently I was only logging on steering angle right now, but I was also logging the raw CAN bus. So only the steering angle, and for me the steering angle was hex 82. So that's 130 in decimal, and then it was the bit 2 and 4, no, 2 and 3, and no, byte 2 and 3, and 8 bits of both. So, and they were signed, I guess, I hope. And also you could just put in the whole hex string into a hex to decimal converter, like in the int function in Python, and you could put this in, and then it would give you the decimal steering angle, and also at the same time it would log the image. So and then it writes the image directly to the disk and adds the label to a label.numpy file, which I can read back when training. So to actually make this a little bit easier to understand, I have my script here for data collection. So if it will focus here, we are essentially, first to explain it fairly quickly, we have a labels array. It contains our it appends our path to the image and also the value of our hex converted int value times the factor we can find over here. We can see the factor is here in the first bracket, between the first bracket and the first row, in the first column. So 0.05 is, we have to multiply that, our steering angle we get from the CAN bus, and then we have to subtract, so we have to subtract 1600 minus 1600. So we're just doing that, and we're basically multiplying and then subtracting. And we save this whole thing to a, when I press Ctrl+C on the terminal window, it says close and saving. It prints the first 50 labels, converts the labels list to a NumPy array to save it afterwards into a labels NumPy file. So explaining the video capture here, the script is going to be open source and it's already in my master branch. The link is going to be in the video description. So this link basically gets the image from the DroidCam. So DroidCam is an app, you download it and you get an USB cable, plug it in, make sure you have USB debugging enabled, and then you can connect it. And so you would open it like that. So let me open a new terminal window pretty quickly here, and we enter Droid, pretty hard to type now. So it finds a video driver. If it does not find that, you can just reinstall it. The instructions are on the DroidCam website, and then you click here USB over ADB, you click connect once, then disconnect, and then run the script. I don't know exactly why this is needed, but it's actually setting up, well, I know why it's needed, because it's setting up the TCP forward. So we're actually port forwarding the Android port to our local PC via ADB, so also make sure you have that installed, and then you're good to go and run the script here, and MJPEG feed basically gives you the video frame. So that should explain the script. So, and what we have here is a Jetson Nano. I'm still waiting for the fan because it gets pretty warm. And my goal with that is actually to put it in a box or in a 3D printed case. I'm still looking for some good options. If you have some good options for cases for the Jetson Nano, just comment it under the video. And so we have a USB dongle here, and also my plan is to buy a 15-inch display I can mount to the into the car instead of the infotainment display, or just put it above it. So I will be running the Panda code on here, and also I will just throw in my USB cable for my phone and for the Panda, and then we're good to go on data collecting. And I'm also trying to set this up for whole Openpilot, so actually getting to work with a webcam Somebody at the Comma Hackathon was doing something similar to that, but I don't know if the code is actually open source. Again, if you notice, please comment it below. And yeah. So actually, to explain this a little more, I have opened the DBC of the RAV4 Hybrid 2016 PT generated file. And here we see the steer angle sensor. It's 37. So when we are going to our script right here, we should have we should replace address with 130 like it is on my Mazda with 37. Yeah, 37. And then it's a little more difficult because the most and least important bits are not the whole byte. So we have to filter out some bits and then only use say 4 bits. So actually what this is doing here is we are starting at pin, well, let me think again. So let me check this here real quick. So I think here the most important bit is the most and least important bits are 30, 23 and 16. So bit 16 starts at practically starts at byte 3, and 23 stops at byte 4. So I only had to process bit 3 and 4, and we're doing that here with the range of the string from the value, and then we are converting this hex value. You always have to think that in the beginning, I'm gonna type it right here, there's always a 0x in the hex value, as it cannot be converted by Python. So you have to keep that in mind when you're changing that. So we have here with the steering angle, the most important bit and least important bits are 3 and 12, and then you also have to multiply by 1.5, and there's no offset. So when you multiply by 1.5, you have the exact steering angle, and you will be storing that in the file down here. And also I have to mention that I tried porting Openpilot to another phone this morning, and it was a Xiaomi. I already tried it in the past, but Openpilot has a new building system right now, or it was added in 0.7, I think. It's called Scones, and I thought let's give it a try, but it seems like Comma changed so much and they require so many dependencies that it's not so easy to actually get from the getting from the all the high level dependencies and getting those installed. And also Comma made a lot of changes to the environment variables, so usually there's no such you're not really using the root user on, or the super user on Termux, but with Comma they heavily rely on those pseudo rights. And also those newer Android versions have so many dependencies that it takes hours and hours to build just to see it fail in the end. And yeah, that's quite a hassle. And also Comma decided to no longer open source the Eon NeoS or the source code, and yeah, that actually makes it practically impossible to continue working on actual phone or hardware ports. The only things that are possible or feasible right now are porting to Jetson Nano and also to some SoC boards with Snapdragon processors on it, but they're like highly development versions. And also, yeah. And also, Comma also, but so Openpilot heavily relies on SNPE, which is not supported on ARM processors. So we would have to write a different backend. So a different with Keras, they open source the Keras files now. So if we could get Keras and TensorFlow all installed on those other phones, and we would also have the manager running with the no board and passive zero environment variables, then we could theoretically get the other stuff to work too. And yeah, if you're interested, just follow my GitHub. So it's now quite a bit later, and I guess that's it for Openpilot Data Collection Day 1. So thank you for watching. If you liked or enjoyed the video in a way, please give it a thumbs up, and see you in the next one.